Hello everyone. So today we are solving this problem number of subarrays with odd sum. So basically given an array of integer array. Okay. So return the number of subarrays with odd sum. So basically for example we are given one array and we have to find how many subarrays are there which makes the sum equal to odd. For example see here these are the subarray of this array. Okay. This array has these many subarrays. But out of these subarrays, we have to extract how many subarrays are there, which if we sum them, they will give us the uh, odd numbers. Okay, so odd sum basically. So for example, see here, this is the one subarray, but its sum is 1. So this is the one example. But if this is the 1 and 3, so its sum is 4, which is not even, which is not odd. So we will not consider it. But if you look at here, this is another subarray which would be we will consider. Same here, 1, 3, 5. If we sum them up, it would make 9, which is odd. So this also would be one answer. So we can see here there are total 4 such subarrays. This guy would be included. This also would be included. This also would be included, and this guy 5. So we have to find those subarrays. How many subarrays are there? Which if we sum them up, it will make them odd number. So this is what we have to do. So before going to the explanation of the question, let's consider few things. That if we make the difference of odd number with another odd number, what does it give? It always give a even number. See here, 7 minus 3, it is giving us 4. Both of them are odd. Similarly, 9 minus 5, it is giving us 9 minus 5, it is 4, right? Which is again even number. So difference of odd numbers is always a even number. Similarly, difference of even number also always giving us the even number. For example, 8 minus 6 is equal to 2, which is an even number. 10 minus 2 equal to 8. This is also an even number. So remember, if we have the same parity, means both of them are even or both of them are odd, then they will call same parity. And their difference would be always even number. But in case of opposite parity, where when one of them is odd and one of them is even, then this will always give us an odd number. For example, 7. 7 minus 4. What it is giving? It is giving us 3. Similarly, 21 minus 2. What it is giving? It is giving us 19, which is again a odd number. So, in this way we can say that if we have the opposite parity number, then their difference would be always the odd number. So this concept we will be using in our solution. So what is this? What is the approach? Our approach. So for example, let's say we have this array. This is the array that is given to us, and now we have to solve this problem for this array. So we will go in the prefix sum approach. So see here, this is the prefix sum. Okay. So initially, odd count would be 0 and even count is 1. Why? Because we are starting from here, so before that we can consider 0 as the one of the value, right? And 0 is considered as 0%, 2 will be giving us 0. So we can consider that even count is 1. Now what we will do is we will starting from here, from this guy, very first one. So in prefix sum we will keep on summing all of them, right? So when it is coming very first time, this is prefix would be 1, right? Prefix sum value would be 1. Let's say we will call it prefix sum. So its value is 1. So is it even or odd? This is basically odd number, right? So what we will do is, if we have already found an odd prefix, okay, and if we remove that, if we found that on the left side, how many already we have found the even numbers, then these would be the opposite parity. So if we found that difference, that how many already occurred the even count, that means if we remove the difference would be the total number of such subarrays which would be basically having the sum equal to odd, right? So what is the difference here? So prefix sum is 1, even count is 1. So answer would be answer plus whatever the even count we have found. So answer now would become 1 because we are adding this even count to it. Okay. Now because we found the prefix equal to 1, which is an odd number. So odd count would be increased by 1. So now our odd count would become now 1 here. Okay. Now we are coming to here. So prefix sum would be whatever sum we have found plus the next number. So 1 plus 3. So now prefix sum would become 4. So now if it is become 4, this is even number. So even count would be increased. So even count now will become 2. Now because this is even number, we have to check that how many odd counts are there. So see here we have one more odd count. We have odd count equal to 1. So what would be the answer? Answer equal to answer plus whatever odd count we have. So this would be 1 plus 1. Now it would become 2, right? Now we are coming to this guy. This is 5. So 4 plus 5, what it would be? It would become 9. So 9 is n, again what is 9? 9 is odd number. So we will increase the odd count by 1. So odd would become now 2. But now because 9 is odd number, we have to look at how many even counts we have, because we are looking for the opposite parity. We already explained that opposite parity difference is always become the odd number. So see here, this is our, we have found 9 is as an odd number. Then we have to check that how many even counts we have found. So even count we have found so far is 2. That means at this point on the left side there are 2 such sub arrays which are having the sum as even, right? So that means if we make a difference of them, we will get 2 even count, 2 such sub array which will make the uh, odd count or odd sum array, right? So what we will do here, this 2 we would add into the answer. So answer already have value 2. So 2 plus even count. So this will become 4, right? Now we are done. So what is the answer? Answer would be the 4 here. We can verify here as well. See here, if we go 1 is the one answer, right? 3 is the another answer. Similarly, we have 5 is also a subset which has the odd sum. And similarly, we can take 1, 3, 5 as well, because all of them, if we sum up it, is making 9. So now we can verify also. So we can see here there are total 4 such subarray which are having the sum as odd number. So this is what we have got. So basically we are doing in O of n, just we need to traverse, we don't have to need any extra space as well. So see here we are community sum, we are getting the prefix sum, and every time we are keeping the track of odd count and even count. We started even count with 1 because 0 could be considered as even number. So let me show you my corresponding code for it. So see here in the question it is given that we have to, the number could be very high, that is why we are making the modulus with this number. So now these are my variable, you can see even is started with the value 1. Now what we are doing is using one for loop, we are keep on summing the prefix, okay. And now whenever we are finding the prefix as even, then what we are doing, answer equal to answer plus whatever is the odd count, and we are increasing the even count because we have found the prefix sum as even. Otherwise this would be odd number. In this case what we will doing, answer equal to answer plus even. So we are looking for opposite parity and we are increasing the count of odd, and at every step we are making answer equal to answer modulus of that mod value, so that the overflow would not be there. Finally we are returning this answer. So let me execute my code here. Yeah, so let me submit it. So yeah, it is 83.08% faster. So we are taking O of n time and no extra space. So thank you for watching the video, and if you guys have any concern, please make a comment over there.